Hi students, let us continue the maxima and the minima in that theorem. Yesterday we have taken one theorem, that is first derivative test. What is the first derivative test? The first derivative test says that suppose f is a continuous function on an interval I and it is differentiable, then f dash of x is changes the sign from positive to negative. F dash of x changes the sign from positive to negative, then f dash of c or f of c is the local maximum. F of c is the local maximum value. And similarly, f dash of x is changes the sign from negative to positive. In that case, f of c is the local minimum value. Where it changes, that is a critical point. At the critical point, that critical point, f of c, critical point. At that critical point, we need to find the function value, that is the local maximum. Whenever f dash of x changes the sign from positive to negative. Similarly, f dash of x changes the sign from negative to positive. In that case, f of c is the local minimum. Now, based on this theorem only, we just solve one example. Now, let's take the another theorem, that is the second derivative test. First derivative test is taken. Now, the second derivative test, we can compare it. This is also theorem to find the local maximum and the local minimum. Which one is easy? Whether the first derivative test is easy or second derivative test is easy to find the local maximum and the local minimum. That's our look. Okay. Statement. Suppose f is a real function, real and continuous function. F is a real and continuous function on an interval I, and C is any point which is present in a domain of the definition, or C is any point which is present in a interval I. Then f is twice differentiable. F is twice differentiable. That means given function we have to differentiate twice, or given function must be possible to do the take the second derivative. Okay, twice, 2 times derivative should be possible. Twice differentiable, because we can say that f of x is equal to some constant c. We can differentiate this only once. If we differentiate constant function derivative is 0. Zero differentiation, which is not possible to do again. So that reason the given function must be a twice differentiable. For example, if I take an f of x is equal to x, identity function, yes, this function can be differentiated twice. First differentiation, f of x is equal to x, f dash of x is equal to 1, f double dash of x is equal to 0. Okay, in that case. Similarly, f of x is equal to x square, like that. But it should not be a constant function. Or else we can say that the given function should be twice differentiable. It is possible to do the 2 times of differentiation. Okay. Suppose f is a real and continuous function on I, and c is any point defined on its domain, or c belongs to the interval I, and f is a twice differentiable. Then in that first case, what is the first case is nothing but if f dash of c is equal to 0. If f dash of c is equal to 0, f dash of c is equal to 0 means the slope of the tangent at the critical point x is equal to c. F dash of c is equal to 0. If f dash of c is equal to 0, then f double dash of c, should be less than 0. F double dash of c should be less than 0. Less than 0 is nothing but it should be negative. In that case, the f of c is the local maximum value. In that case, f of c is the local maximum value, and c is said to be a point of local maximum. What is the condition of the second derivative test? F is a real and continuous function on I. Then any point belongs to the interval I. F is twice differentiable. In that case, to find the local maxima, what is the condition? F dash of c is equal to 0. This must be f dash of c is equal to 0. If f dash of c is equal to 0, then second derivative of the function at that critical point, second derivative at the critical point should be negative. If this condition is satisfied, already it is that if this is true, then if it is also true, then only we can say that f of c is the local maximum value and c is the local maximum point. Similarly, second point, if reverse, again the same thing, if f dash of c is equal to 0, then f double dash of c is greater than 0. That means second derivative at a critical point is positive. In that case, f of c is the local minimum. F of c is the local minimum value. Okay. If it is f double dash of c is negative, local maxima. F double dash of c is positive, local minima. This two conditions. For the two condition, f dash of c is equal to 0, f dash of c is equal to 0. Next, the third condition. Suppose f dash of c is 0, okay, no problem, and as well as f double dash of c is also 0. In such cases, for example, I just taken beginning, constant identity function f of x is equal to x. First derivative is 1, second derivative is 0. F dash of c is 0 as well as f double dash of c is also 0. In this case, the second derivative test is fails. In this case, the second derivative test is fails. If second derivative test is fails, then we need to know that we need to go back to the first derivative test. We need to go back to the first derivative test. Already first derivative test we know that f dash of x changes the sign from positive to negative or negative to positive. Are you clear about the second derivative test? We will take some examples in this way only. So continuous interval twice differentiable at the point anyhow c belongs to the interval. F dash of c is 0 and f double dash of c is negative. In that case, the f of c is the local maxima. F dash of c is 0, f double dash of c is positive. In this case, it is a local minima. If both are 0, the second derivative test is fails. We cannot decide or we cannot find the local maxima or local minima using the second derivative test. So that once again we go back to the first derivative test. So suppose if you ask in an examination, find the local maxima and the local minima. So directly go use the second derivative test. We can easily find the second. We can easily find it. Local maximum value, local minimum value. We will solve one particular example. We come to know it. Yes. Example is find the local maxima and local minima of the function is given by f of x is equal to 3 into x over 4 plus 4x cubed minus 12 into 2x square plus 12 is that. For this polynomial function of the degree 4, fourth degree polynomial function is that this polynomial function local maximum value, local minimum value. Already know that local maximum and the local minimum value, how it is. There are so many maximum and minimum values are there in the domain of the definition in the given interval. Out of that, locally we have to choose. How to choose the locally means at this is at x is equal to c. So it is a local maximum value at x is belong to the c minus h comma c plus h locally. So already know that meaning of the previous video I already explained. Okay. Out of that, there are several maxima, several minimum value locally at the critical point. Whatever the critical points are there, all the points local maxima and the local minimum value we have to find it. And now here for this fourth degree polynomial function, we have to find the local maxima and the local minima. I just use the second derivative test. Already know the second derivative test. It should be a twice differentiable continuous function. No doubt at all, polynomial function is continuous. What is the domain of the domain of the function? Whole real number set is the domain of the function. So differentiate the given function with respect to x. What happens? F dash of x is equal to 4 3s are 12 into x cubed plus 4 3s are 12 into x square minus 24 times of x plus 12 differentiation is 0. Again, or else before we take the second derivative, I just call this as the equation number 1 and this is the equation number 2. Okay. I just rewrite this one f dash of x. What is the f dash of x can be written is factorized form I need to write because we have to find the critical points. So that reason I am just going to write the factorized form. So 12 into x is common. If I take a 12x is common, what is left? X square plus x minus 2 is left. Okay. 12 into x into x square plus x minus 2. What are the factors? Can be written as, okay, this is x square plus 2x minus x minus 2. Okay. Now 12 into x. Now here in this square bracket x is common, x plus 2 is left, minus 1 is common, x plus 2 is left. Factorize form. 12 into x into x minus 2 is common, x plus 2 is common, again x minus 1 is left. Okay, this is our f dash of x. Now, after rewriting the f dash of x, I just call this as equation number star. Okay, now what I just do here means I just again differentiate the equation number 1. Differentiating the with respect to x for the equation number 2. What will get the f double dash of x? What is the f double dash of x? Equation number 2, differentiating, because it is product we have to use instead of differentiating, differentiate this one. 12 into 3, 36 into x square plus 24 into x minus 24. This is the f double dash of x. This is our equation number 3. Now what we need to find? We have to find that the local maximum and the local minimum value. So that reason I just continue here. The solution is continued here. So how to find the local maximum and the minimum? By differentiation is over. First derivative write in the factorized form. Why we are writing this in the factorized form? We'll just come to know it. Because to find the critical point, it will be very easy as solving this one. Anyway, and how to decide it? Anyway, so here suppose f dash of x is equal to 0. Suppose f dash of x is equal to 0, because I am just taking the f dash of x is equal to 0 means if f dash of c is equal to 0 is there. So that is a critical point where curve changes its direction, and that value we need to find. If f dash of x is equal to 0, what is the f dash of x? Here is my f dash of x. Equation number star implies. Equation number star implies. What is that? 12 into x into x plus 2 into x minus 1 is equal to 0. How many number product is that? 4 number product is that. 4 number product is equal to 0. Any one of the number is 0. 12 is not possible to become a 0. Either x is equal to 0 or x plus 2 is equal to 0 or x minus 1 is equal to 0. From this, either x is equal to 0 or x is equal to minus 2 or x is equal to plus 1. There we just get the 3 critical points. Out of these, all these 3 critical points, the curve changes its direction, increasing to decreasing or decreasing to increasing, like that. Now, what we have to do means we have to check the sign of the f double dash of x. These are all the c value. So c is equal to, this is also c is equal to, and this is also c. These are all the critical points. F dash of c is 0. At this point, f dash of x is 0. Now, so these are all the critical points. Now, at these 3 critical points, what about the sign of the f double dash of c? Whether it is the positive value or negative value. Let's have a look on that side. Okay. So first of all, at x is equal to 0. Suppose at x is equal to 0, what about the f double dash of c? F double dash of c is nothing but equation number 3 implies. F double dash of 0 is positive or negative. That's the only thing we need. F double dash of c, 36 into 0 plus 24 into 0 minus 24 is left. F double dash of 0 is minus 24. That means the second derivative at the critical point is negative, unless is less than 0. If it is less than 0, according to our condition, theorem number, second derivative test, what we can say? F dash of c is 0. F double dash of c is negative. F double dash of c is negative. In that case, it is a local maxima or local minima? It is a local maxima. Therefore, x is equal to 0 is the point of local maximum. F double dash of C is the point of local maximum. But we need to find that local maximum value. So what is the local maximum value? F of 0 is the local maximum value. There, F of C is the local maximum. So for the given function, wherever x is there, replace the 0. It is 0, 0. This is also 0. 12. This is the local maximum value. This is the local maximum value. One critical point value is over. Now, at x is equal to minus 2. What is the equation number 3 implies? At x equal to minus 2, what is the equation number 3 implies? So that means f double dash of minus 2. F double dash of minus 2, equation number 3 implies minus 2 square is equal to 36 into 4 plus 24 into minus 2 minus 24. What is the value? 36 into 4. 144 minus 48 minus 24. On adding this 48 minus 24. Minus 48 minus 24, that is 72. 144 minus 72 is equal to again 72. Okay, plus 72. Plus 72 is positive. F double dash of minus 2 is plus 72. So F dash of C is 0. F dash of at x equal to minus 2, it is 0. And F double dash of C is positive. In that case, x is equal to minus 2 is the point of local maximum or local minimum. It is a local minimum value. Similarly, we can find the local minimum value. What is the local minimum value? F of minus 2. What is the f of minus 2? Wherever given function is there, replace the x value as minus 2. So that is 3 into minus 2 power 4 is 16 plus 4 into minus 8 minus 12 into 4 plus 12. Simplify this value. What is this value? 48. 3 into 16, 48 minus 32 minus 48 plus 12 is equal. So plus 48 minus 48 get cancelled. Minus 32 plus 12. That means minus 20. This is the f of minus 2. It is the local minimum value. It is the local minimum value. And one more point is there. What is the one more point? X is equal to 1 is there. I will just continue here. At x is equal to 1, what will get? At x is equal to 1, the equation number 3 implies. What is the equation number 3 implies? At x is equal to 1. So f double dash of 1 is equal to 36 plus 24 minus 24 plus 24 minus 24 get cancelled is equal to 36. It is positive quantity. F double dash of C is positive. If f dash of C is equal to 0, f double dash of C is positive, then it is nothing but local point of local minimum. Point of local minimum. I am just using the second derivative condition, second derivative test condition. That's all, nothing more than that. Now, f of 1 is equal to, what is the f of 1? F of 1, wherever x is there, replace the 1 at here. 3 plus 4 minus 12 plus 12. Plus 12 minus 12 get cancelled. 3 plus 4 is equal to 7. It is a local minimum value. There are two local minimum value, one local maximum value. What is the local maximum value? 12 is the local maximum value. Minimum value, local minimum value is minus 20 as well as the plus 7. And in some cases, in some problems, the local minimum value might be more than the local maximum value. Have you got my point? In some problems or some situations, the local minimum value might be more than the local maximum value because we are discussing the locally. So locally, in the given interval, this local maximum value and local minimum value might be varied. So I'm just taking only in this interval, this interval, this interval, this interval, this interval, like that. I'm just splitting. All the domains that I'm just splitting nearer to the critical points. Nearer to the critical, little bit negative and right hand side. Only small interval I am just taking. Suppose it is a local maxima, I am just taking a small interval. In this interval only, it is a maximum value. It is a local maxima, so that in this interval only, it is a maximum value. It is a local minima. In this interval only, it is a minimum value. That means we say that local minima and the local maxima. So this is how we have to solve the problems. Very simple. If they ask find the local maxima and the local minima, find the first derivative and second derivative. First derivative equal to 0, you will get the critical point. After getting the critical point, for all those critical points, you have to check the second derivatives. Second derivative at that critical points, whether positive or negative. If you got it as a negative, that is the point of local maximum. If the second derivative is negative, positive, then if the second derivative is negative, that is the point of local maxima. If the second derivative is positive, then it is a point of local minima. So you can compare it, whether the first derivative test is easy or second derivative test is easy. Solve it. The same problems on using the first derivative test as well as the second derivative test, we can come to know that which one is easy method to find the local maxima and the local minimum. Okay, so my suggestion is better to use the second derivative test only. If whenever both first derivative as well as second derivative are equal, then only you just go back to the first derivative test. Okay, so in the examination, they will not particularly ask use the second derivative or use the first derivative. You can use any derivative test. So ultimately, we have to get the local maxima and the local minima. Whatever the theorem you can visit, the answer will be same. There is no change in the answer. Okay. Now let's move to the next example. Yes, next example. Find the local maxima and local minima if any, if exist. The local maxima, local minima, find that value of the following functions. In that, first one, f of x is equal to x square. First of all, is it a continuous function? Yes. Y is equal to x square. X square is equal to 4ay, upward parabola. Obviously, it is a continuous function. And twice differentiable. Is it possible to differentiate 2 times? Yes, obviously, we can differentiate 2 times. No need to worry. Okay. Now, we need to find the local maxima and the local minima. So, how do we find? First of all, differentiating with respect to x. F dash of x is equal to. What is f dash of x? X square differentiation is 2x. And again differentiating. You can say that again differentiating with respect to x. F double dash of x is equal to 2x differentiation is 2. And now I just call this given equation number 1, this equation number 2, and this is equation number 3. So now we need to find that critical point. So that suppose f dash of x is equal to 0. Suppose f dash of x is equal to 0. What is the value? F dash of x, 2x. 2x is equal to 0. That means x is equal to 0. There is only one critical point. If x is equal to 0, what will get? So at x is equal to 0, what is the f double dash of x? At x is equal to 0, what is f double dash of x or f double dash of c? C value is a 0. F double dash of c is equal to second derivative test right hand side independent of x, constant term. Whatever the x value, it is always positive because it is a constant function. So it is 2 and it is a positive value. We need only positive or negative, no need to get the value. So we can write whether it is a positive or negative. Very carefully you have to calculate it. So that means x equal to 0 is the point of local maximum or point of local minimum. F dash of x is equal to 0 and f double dash of c is positive. Therefore, x is equal to 0 is the point of local minimum. Point of local minimum. Second condition. F dash of x is equal to 0, f double dash of c is positive, then it is a point of local minima. We need the local minimum value, so that f of 0. What is f of 0? Wherever x is there, replace the 0. This is the local minimum value. This is the local minimum value. As we know that graph of the upward parabola, this is the upward parabola, this is the particular graph of this function. Now you can observe that in a first class of the maximum minima, the same example is found out. The minimum value is 0. What is the minimum value? Is 0. Here also the same value. In first class also it is for the same value. There exists a maximum value? No, there does not exist a maximum value. As increasing the x value, the function value is also increasing, which is not possible to get the maximum value. Are you clear? So this function exists only the minimum value, that is said to be a local minimum value. There does not exist any maximum value. That's all. Clear? Very simple. First derivative, second derivative, first derivative. If it is possible to do factorization form, write in the factorization form, equated to 0, we will get the critical points, and at that all the critical points, check the sign of the second derivative. Then if it is second derivative is equals to local minima, if the second derivative is negative, local maximum. Very clearly observe this. Reverse. Second derivative is negative, local maximum. Second derivative is positive, local minimum. Are you sure? Okay. Now let's move to the next example. In the same manner, find the local maximum and the local minimum. That is f of x is equal to x cube minus 3x. F of x is equal to x cube minus 3x. Okay. So what is the local maximum and the local minimum? Let's carry on. First derivative, f dash of x is equal to, and one more thing we can mention it by the second derivative test. By the second derivative test, this is the thing happen. Okay, f dash of x is equal to 3x square minus 3. Now write in the factorized form. F dash of x is equal to 3 is common, x square minus 1. Given equation number 1, this is the equation number 2. Now, I just call this is the equation number 3, doesn't matter. Now, again differentiating with respect to x. Again differentiating the equation number 2 with respect to x. What is the differentiation of the equation number 2? That is f double dash of x is equal to 3 2s are 6 times of x. Now, call this as equation number 3. Now, find the critical points. You can pause it and find it. Suppose f dash of x is equal to 0. F dash of x is equal to 0 means better take the factorized form or take the original f dash of x, doesn't matter. If f dash of x is equal to 0, what happens? 3x square minus 3 is equal to 0, or else I just take the factorized form. 3 into x square minus 1 is equal to 0. Product of two number is equal to 0. Either first number or second number is 0. First number, that is 3. 3 never becomes a 0. So that either x square minus 1 is equal to 0. X square minus 1, again we can rewrite. This is 3 into x plus 1 into x minus 1, factorized form. So x square minus 1 is nothing but x plus 1 into x minus 1 is equal to 0, which implies either x is equal to minus 1 or x is equal to plus 1. X plus 1 is equal to 0 or x minus 1 is equal to 0. So that x is either minus 1 or plus 1. Now, check. These are the two critical points that we discussed the c value. Now, at x is equal to minus 1, by using the second derivative test, we have to compute. F double dash of minus 1. What is the f double dash of minus 1? 6 into minus 1 is minus 6. It is less than 0. It is less than 0 means it is a local maximum value or local minimum value. It is a local maximum value. Second derivative is negative. So that it is x equal to minus 1 is the point of local maximum. Is the point of local maximum. And we need to find that. What is that local maximum value? So that f of minus 1 is equal to f of minus 1. We will get the local maximum value minus 1 minus minus plus 3 is equal to 2 is the required local maximum value. Is the required local maximum value. Now I just continue here. Up here next at x is equal to 1 more point is plus 1. At x is equal to 1, what will get? At x is equal to 1. By the second derivative test, you have to double dash of 1. What is the double dash of 1? At x equal to 1. At x equal to 1, you have double dash of x is 6. Positive value greater than 0. Greater than 0 means x equal to 1 is the point of local maxima or local minima. It is the point of local maxima because second derivative is positive. Therefore, f of 1. What is f of 1? F of 1 is equal to 1 minus 3. 1 minus 3 is equal to minus 2. So minus 2 is the local maximum value. Minus 2 is the local maximum. Once again, it is not a maximum value, it is a minimum. Local minima. It is a local minimum value. What is the local minimum value? Local minimum value is minus 2 and local maximum value is plus 2 for the function f of x is equal to x cube minus 3x. Now, let's move to the next example. Yes. Third one. F of x is equal to x cube minus 6x square plus 9x plus 15. You can pause the video and solve the problem. Later you can cross verify. And one more thing. Those who are not understood still at all, just observe very clearly. Very simple. So I am just using the second derivative test. Second derivative test I am just going to use to find the local maximum and the local minima. So first find the f dash of x equated to 0, then f double dash of x, and whether it is a positive value or negative value. If it is negative, it is the local maximum value. If it is positive, it is the local minimum value at a particular point at the critical points where the f dash of x is equal to 0. Okay, and just remember this one, and very simple, we can easily solve the problem. Okay, differentiating. F dash of x is equal to 3 times of x square minus 12 into x plus 9. Now, I just write this one in the factorized form. How we can write? I just take 3 is common. If you take 3 is common, x square minus 4x plus 3. What will happen? 3 into x square minus 3x minus x plus 3. Okay. So again 3 into x is common out of these two terms. Okay. What happens? X minus 3, and here minus 1 is common. X minus 3. 3 into one term is x minus 3, another term is x minus 1. This is our f dash of x. This is equation number 1. And this is called as equation number 2, and this is equation number star or 3. Now again differentiating the equation number 2 with respect to x. What happens? You have to double dash of x, differentiating the equation number 2 here. 3 2s are 6 times of x minus 12 into 1. Call this as equation number 2. Now we have to take by using the second derivative test. By second derivative test, or else before that, first find the critical point. Suppose f dash of x is equal to 0. F dash of x is equal to 0 means I just take the equation number star. That is equation number star. I am just going to consider. Simply we will get the result. Okay. So here equation number star 3 into x minus 3 into x minus 1 is equal to 0. And one more thing, I can do this part at right now here, or else we can do at this moment, taking f dash of x is equal to 0, getting the critical point. Either you have to do here or you have to do here. Ultimately you have to do once, you have to compulsory you have to do it. Right? So product of 3 number equal to 0, any one of the number is 0. 3 number becomes 0, x minus 3 is equal to 0, or x minus 1 is equal to 0. From this, x is equal to 3 or x is equal to 1. So these are the critical points where the curve changes its direction. Now f dash of x is equal to 0, which is called that point which is called as a 3 and c 1 and 3, which is called. Now check the second derivative sign by the second derivative test. At the particular point x is equal to 1. F double dash of 1. What is the f double dash of 1? F double dash of 1 is, where is the f double dash? Here is our f double dash. 6 into 1 minus 12 is minus 6 is less than 0. Second derivative at a critical point is negative. That is nothing but a local maxima. So x is equal to 1 is the point of local maximum. Point of local maximum. Similarly, and local maximum value is f of 1. So this is f of 1 in a given function. Replace x value is 1. 1 minus 6 plus 9 plus 15. What is the value? 1 minus 6 minus 5. Minus 5 minus plus 15. 10. 10 plus 9 is equal to 19. 19 is the required local maximum value. Therefore, 19 is the required local maximum value. 19 is the required local maximum value. Next, and one more point is that at x is equal to plus 3 is that at this point, what is that? You have to double dash of 3. Whether you have double dash of 3 is positive or negative. Where is the double dash of x? Here, 6 into 3, 18. 18 minus 12. 18 minus 12 is 6. 6 is nothing but positive. It is positive. No need to write this 6. You can write directly whether it is a positive or negative. That's enough. Positive. That means it is the point of local maxima or local minima. It is the point of local minima. Therefore, local minimum value is f of 3. What is f of 3? 3 cube is 27. Again, 3 square 9. 9 into 6, 54. And 9 into 3, 27. Plus 50. Simplify. Plus minus 54 is that 27 plus 27. 54. 54 can cancel is equal to 50. Are you clear? 27 plus 27. 54. Okay. 50. This is the, what is the value? Local maximum or local minimum? This is the local minimum value. Local minimum value is 15. Local maximum value is 9. Here just observe that local maximum value and local minimum value. Here local maximum value is 19, but local minimum value is 15. Okay, it's true only, but very close at value. Sometimes local minimum value is more than the local maximum value. Okay, now let's move to the next example. Yes, fourth one. F of x is equal to sin x plus cos x, where 0 is less than x is less than pi by 2. Function is sin x plus cos x. Sum of the trigonometric functions is given. Trigonometric equation or trigonometric functions. And what is the domain of the function? Here the whole real numbers is not a domain. Already know that regular sin and the regular cos function, domain of the function is whole real number and range is -1 to +1. But here sum of sin x and cos x. What is the domain? Domain is 0 is less than x is less than pi by 2. That means open interval 0 comma pi by 2 is given. This might be also written as 0 comma pi by 2 open interval. Open interval means n points are not included. Okay, at this interval we have to find the local maximum and the local minimum value. Okay, f dash of x is equal to differentiate. This is for cos x, sin x differentiation is cos x differentiation is minus sin x. Okay, now again differentiate. F double dash of x is equal to minus sin x minus cos of x. We can take the minus outside, sin x plus cos x. Sin x plus cos x is nothing but originally f of x. Okay, now suppose find the critical point, so that suppose f dash of x is equal to 0. F dash of x is equal to 0 means what? Cos x minus sin x is equal to 0, which means that so already solved the trigonometric equation. Now I just write the cos x is equal to sin x. So you just solve a trigonometric equation. Now directly I am just going to write this value as x is equal to pi by 4 because one but here domain of the function is first quadrant is there. I just consider only the first quadrant value. Are you clear? Domain is first quadrant, so that first quadrant at which angle it is equal at x is equal to pi by 4. So this is our critical point. At this point, second derivative, you have to double dash of pi by 4. What is the double dash of pi by 4? You have double dash of pi by 4 is equal to minus is outside into sine of pi by 4 plus cos of pi by 4. What is the sine pi by 4? 1 divided by root 2 plus cos pi by 4 1 by root 2 is equal to minus 2 divided by root 2. That is nothing but minus root 2. Minus root 2, it is a negative quantity or positive quantity? Negative quantity. It is negative means x is equal to pi by 4 is the point of local maxima or local minima. It is the point of local maxima. Point of local maxima means find the local maximum value. So f of pi by 4. What is f of pi by 4? Sin 40 pi 1 by root 2 plus cos 40 pi 1 by root 2. So what is the 1 by root 2 plus 1 by root 2? 2 divided by root 2, which means that root 2 is the required local maximum value for the function sin x plus cos x in the interval or in the first quadrant or in the interval 0, pi by 2 open interval. So this is how we have to find the local maximum and the local minimum. Now next problem is yes, f of x is equal to 1 divided by x square minus x square plus 2 is there. Okay, find the local maximum and the local minimum if any. Okay, so I just take directly f dash of x is equal to 1 by x differentiation minus 1 by x square minus 1 divided by x square plus 2 whole square. But in place of x square plus 2, differentiation of x square plus 2 is 2x. Okay, now again differentiating this value. So or else f dash of x is equal to minus 2x divided by x square plus 2 whole square is there. Now again differentiating. Again differentiating with respect to x. F double dash of x is equal to, I just keep the minus to outside. Use the quotient rule. X differentiation is 1, so x square plus 2 into whole square minus u dash into 3 into minus u is nothing but x minus 2 I just taken outside into v dash. What is the v dash? Denominator term differentiation. Whole square is 2 into x square plus 2 into x square plus 2 differentiation is 2x. U into v dash divided by v square. V square is nothing but x square plus 2 whole square. That whole square is nothing but whole power 4. Now rewrite. What we can rewrite? Minus 2 is outside. Keep as it is. Here can I take the or else keep as it is. X square plus 2 whole square minus x into 2x. Here also 2 is 2 2s are 4. 4 into x square plus 2 whole thing divided by x square plus 2 whole power 4 is that. 1 x square plus 2 can take common and cancel it. Nothing 12. Okay. 1 time of x square plus 2 is common and cancel it directly. So x square plus 2 minus 4 into x square divided by x square plus 2 whole power 3. Call this as equation number star. Are you clear? 1 x square plus 2 is common and get cancelled. X square plus 2 whole cube is left. Okay. This is our f double dash of x. Now we have to find at the critical point it is a positive quantity or negative quantity. So find the critical point. How to find the critical point? Suppose first derivative is 0. Suppose f dash of x is equal to 0. If f dash of x is equal to 0 means here is our f dash of x. What is that? Minus 2x divided by x square plus 2 whole square is equal to 0. Cross multiply and simplify. 0 into this number is 0. So that implies x is equal to 0. So by the second derivative test at x equal to 0, what is the f double dash of x? That is f double dash of 0 is equal to, wherever x is there, replace 0. This is minus 2 as it is. 0 plus 2 is 2 minus 4 into 0, this is 0 divided by 0 plus 2, 4 cube is that 0 plus 2, there is nothing but 2 cube is 8. Okay, minus 2 ones are 2 fours are 2 ones are 2 twos are minus 1 by 2. It is a negative quantity. If it is a negative quantity, that means x equal to 0 is the point of local maxima. Point of local maxima by f dash of x is equal to 0 and f double dash of x is negative. Therefore, it is a point of local maxima. We need to find the local maximum value so that f of 0 is equal to, what is f of 0? F of 0 is 1 by 2. 1 divided by 0 plus 1 by 2. It is the local maximum value. This is the local maximum value of the function 1 divided by x square plus. Okay. So this is how we have to solve the problems on using the second derivative test. Just practice this type of problems from the exercise. Here I just solved some problems on the exercise only. So practice those exercise problems till this problem, and the remaining problems will continue in the next video. Okay, thank you.